All right, we're going to continue with Section 1.1 video. This is part 3 video. In the last video, you went ahead and copied all of the problems down that we would work. So the ones that we're about to work, you've already copied these down in the previous video. Now, if you didn't watch the previous video, you need to go back to the beginning of that video so that you can get all of these written down, so that you can have these as I go through and work these. All right. In this part of the video, one of the things that we're going to do is I'm going to show you how to solve an equation. That means it's got an equal sign if it has fractions in it. Now, you can have 4 different teachers and they can teach this 4 different ways. So when you view an example in your homework, I talked about that in one of the videos, they may teach it a little differently than I do. I do not require that you do it exactly the same way that I do it, as long as what you do is mathematically correct. I would, however, suggest that you do it the way that I teach it. One reason is I feel it's the easiest way for you to pick up on. So, but you know, you follow whatever you want to do there, but I would suggest that you do it the way I'm going to teach it. So this is me. Anytime I have an equation, means it's got an equal sign, and I've got a fraction anywhere in that problem, I get rid of all of the fractions first. Now, how do we do that? Well, a couple of questions first. If I have an adding 7 on one side, and I want to get rid of an adding 7, I just simply subtract 7 from both sides. Or if I have the subtracting 3, I add 3 to both sides. Now, what if I want to get rid of a multiplying 3? Like 3x equal 24. That's 3 times x. How do you get rid of that 3 times x? You get rid of the times 3 by dividing by 3. Well, what is a fraction? A fraction is a dividing number down here. So if adding and subtracting undo each other, and multiplying and dividing undo each other, how would I get rid of a dividing 3? I would multiply by 3. But whatever you multiply one side by, you have to what? Multiply the other side. Now, before I get into that, I want to show you something right quick. Whenever you multiply a side by something, you don't have to copy this. Multiply a side. It is not the same as when you add a number to a side. Let me show you an example. Let's suppose I have 5x plus 3 equal to whatever. Don't worry with what's on the other side. Now let's suppose I told you this. I want to add 7 to both sides. First of all, is that allowable? Yes. You say, Mr. Trainer, why would you want to add 7 to both sides? Don't worry with that. Just follow along with me here. Suppose I told you to add 7 to both sides. Is that mathematically okay? Yes. All right. So if I add 7 to this side and add 7 to this side, that's okay. When I do that, what do I have now on the left side? 5x plus 10. What I want you to notice is when I added 7 to both sides, you add the number to the number. You don't add it to the 5x because they don't add together. So you add these two together. So when you add a number to both sides, you only add it to the number that's already on that side. Same way with subtracting. That's not true with multiplying. Let me show you. So let's suppose, start over. Suppose I have 5x plus 3 equal, doesn't matter what's on the other side. Now, let's suppose I said multiply both sides by 7. So I want to multiply 7 times this side. Now, if you'll remember, we have what's called in mathematics called a distributive property. That is when you multiply by a number. So I'm multiplying 7 by this side. Now, you can't add 7 to this, but can you multiply it? Yes. So when I multiply 7 by this side, you have to multiply it by both of these terms. This term and that term. That's where the word distributive property comes in. So, is there a difference when you add a number to both sides as opposed to when I multiply a number? It's very different. When you multiply a side, it has to be every term on that side. And really, same way with dividing. Divide, you have to divide every term on both sides. So, I'll refer back to that in just a few minutes. Okay, so the last example that we had worked together was number 6. So I want to pick up here with problem number 7. You've already written it down, so you don't have to copy it. You can just sit back and watch. So I've got x over 3 equal 4. All right. Let me say again before I work this problem. There are multiple ways to work this problem. I would suggest that you work this problem the way I'm about to show you. I think it's the easiest. Okay, so what do we do here? First thing when I look at this problem, what's the first thing you see you don't like? Me either. I don't like the fraction. So here's what we're going to do. A fraction is a dividing 3. So how do you get rid of a dividing 3? You multiply by 3. But whatever you do to one side, you have to do to the other. So here's what I'm going to do. To get rid of this dividing 3, I'm going to multiply by 3. But whatever you do to one side, you have to do to the other. Now, one other thing I want to remind you about is this. Remember, when multiplying with fractions, you can cross cancel. So when you get right here, don't say 3 times x. Cross cancel first. Cancel out your fractions. Now, when you do, 3 goes into 3 one time. And so you're left with 1x, or just x, equals, and then 4 times 3, which is 12. Okay, let's do another one. Number 8. 2/3 x equals 1/2. All right, what's the first thing you see in this problem that you don't like? You don't like the fractions, do you? Nor do I. So here's what I'm going to do. I'm going to get rid of the fractions. How do I do that? By multiplying both sides by something. Well, I have to get rid of a dividing 3. But I also have to get rid of a dividing 2. Now, question. Would it be okay if I multiply one side by one number and the other side by a different number? No, that's not okay. You have to multiply both sides by the same number. So, I've got a dividing 3, and then I've got a dividing 2. So, if I want to get rid of a dividing 3 and a dividing 2, I'm going to have to multiply by a big enough number that they both cancel with. Well, tell me what number 3 and 2 both divide into. They both divide into 6. We call that the LCD. And if you'll remember, step 1, 2 videos back that I gave you was multiplying, to get rid of fractions, multiply each side of the equation by the LCD. So what I want to do here is I want to multiply both sides here by the LCD, which in this case would be 6. So I want to multiply this by 6 and this by 6. Now let me mention this also. Because there's no adding or subtracting sign right here, this is considered to be one term. It's not 2 terms. I know when you look at that, you see 2 things. But there's a multiplication symbol there that holds that term together. It's kind of like glue. Multiplication does. So this is one term, not 2. If it was a plus or a minus, it would be 2 terms. All right, so multiply by 6, multiply by 6. You'll hear me say this every single time right here. Cross, cancel first before you do anything else. Because the purpose is to get rid of the fractions. 3 goes into 6, 2. 2 goes into 6 3 times. Now all of the fractions are gone, So multiply what's left. 2 times 2x is what? 4x equals 1 times 3, which is 3. And there it is again, ax equal b. Divide by the number in front of x, unless it's 0. So I get x equals to 3 over 4. And that does not reduce. Okay? Now, let's look at the next example. X over 3 minus 2 equals 1/4 minus 2x over 3. Let me see if I've got a color pen here. Give me just a second. Sorry about the racket. Okay. All right, what's the first thing you see here that you don't like in this problem? Well, I don't like the fraction. So I've got a fraction here, a dividing 3, a dividing 1. That 2 is in the top. This is 2 over 1. So you got a 3, a 1, a 4, and a 3. So I need something that 3 and 4 both go into evenly. That's 12. So what I want to do is I want to multiply by 12. Now, I've had students ask before, they say, well, Mr. Reiner, what if I was thinking 24? It doesn't matter what you multiply by as long as all of your fractions, all of your denominators go into that number. So if you use 24 and you reduce your answer, you'll still end up with the same answer. All right. Now, what have I got to do? I got to multiply by 12. Well, when you multiply, it's every term on both sides. Now, if you look at this left side now, that's 2 different terms. And over here is 2 different terms. So when I multiply, I'm going to have to put a 12, distribute by every one of these. Well, I don't want to do it in my head. It's easier for me just to put the 12 by every one of these. Because there's 4 terms. 1, 2, 3, 4. You need to put a 12 by every one of those. It's distributive property. All right. Cross, cancel first. So, this 3 cancels with that 12 and leaves 4. Be careful right here. Don't say 2 into 12 is 6. That 12 and 2 are both in the top, so there's no canceling there. Here is canceling, because this is in the bottom. 4 into 12 leaves 3, and then 3 into 12 leaves 4. Now multiply what's left. 4 times x is 4x, minus 12 times 2, which is 24, equals 3 times 1, which is 3, minus 4 times 2x is 8x. All right, now all of the fractions are gone. Now you're back to that 2-step process. Get your x's on one side, numbers on the other. And you do that in as few or as many steps as you want to. So get the x's on one side, numbers on the other. So this is 12x equals to 27. Let me say once again, if this had been 4x minus 4x, this would be 0x equal 27. If that happens, it's no solution. If it's 0x equals 0, the answer is all real numbers. So see, you can still run into those 2 scenarios even with the fractions. Now divide by the coefficient of x. I can do that because it's not 0. And then 27 over 12 will reduce because 3 goes into both of those. 3 goes into 27, 9. 3 goes into 12, 4 times. Okay, let's look at one more example with fractions. All right, several little things you need to be careful about right here. But before we get to that, you're going to have to listen carefully because you got several of these in the homework. All right, first thing I'll do is when I look at this equation, I don't like the fractions. So this is a dividing 6, a dividing 1, a dividing 5. So 5, 1, and 6 is 30. Now, you say, well, Mr. Randy, could I always just multiply all the denominators out? Will that work? Yes. It may give you a bigger number. For instance, if I had a dividing 4 and a dividing 8, a dividing 4 and a dividing 8, the best number to multiply by would be 8. Now, could you say 8 times 4 and use 32? Sure. But you're just dealing with bigger numbers, which is still okay, as long as you reduce your answer. All right, so I've got a dividing 5, a dividing 6, so I'm going to multiply by 30. Now, remember when you multiply, you don't multiply every fraction by 30. You multiply every term by 30. It's distributive. So if you'll look, here's the equal sign right here. There's one term on this side. This is one term because it's one big fraction. So this is not two terms because it's one big division bar. So that's one term. But over here, you got one term there, and you have one term there. So really, you have 3 terms in this problem. So you have to multiply all 3 by 30. All right, so let's do that. So put 30 here, 30 here, and 30 here. And again, you've already copied this. So, all right, now my 3 famous words. Cross, cancel first. So you get rid of those fractions before you start doing any multiplication. All right, so this would be 6 into 30 leaves 5. Don't say 2 into 30. Both of those are in the top. So 6 into 30, that's 5. 5 into 30 is 6. Now multiply what's left. Now this is the next thing you have to be careful about. When you say 6 into 30 leaves 5, this 5 has to multiply everything that's in this top. So it's not 5x plus 4, it's going to be 5x plus what? 20. So this 5 has to multiply everything that's in this top. So that's going to be 5x. After you cancel, you distribute to get what's left. So that would be 5x plus 20. Equals. Now, 30 times 2 is 60. Minus. Now, be careful right here. How many times did 5 go into 30? 6 times. Now, what have I got to do to this 6? Multiply everything that's in the top. But don't forget that this 6 is negative. So it's negative 6 times x, which is negative 6x. But it's negative 6 times a positive 3. Negative 6 times a positive 3 is negative 18. Negative 6 times x is negative 6x. But then negative 6 times 3 is negative 18. And that's where we usually make the mistake right there. Okay, now you can't do anything to the left side. The right side would be, bring down the negative 6x, and then 60 minus 18 would be plus 42. Now get your x's on one side, get your numbers on the other. And this would be 11x equals to 22. Divide by 11. To get x equal to. One solution to that problem. Okay, so that concludes Section 1.1 video, Part 3. We have one more video. It'll be a short video, But we have one more video on section 1.1, and that will be linear equations that involve decimals, and you've already written those two problems down. So next video, part 4.